Let's first add the file obstacle.js in which we will add our obstacles, whatever obstacles we need, like the rotator one. So like in the original game, we have our rotator obstacle, so let's add a class of that in which we will have multiple colored arcs which will rotate and the player can pass through it. So first in the constructor, let's define its x and y position. So x will be width divided by 2, that means in the horizontal center, and y will be also height divided by 2. For now we are keeping it vertically center. Now for this obstacle to interact with the player, we also need the player object. So let's pass this player object into the constructor and let's keep this player's information into the variable this.player. And as we are creating a ring which is rotating, which have 4 arcs with different colors, we need colors array which have 4 colors, different colors, which we will generate randomly by using our colors class which we created in the previous video. We also need an offset variable for rotating this ring. You will understand why we are doing this once we draw the ring. So initially the offset is 0. Now it's time to draw the ring. So for drawing the ring, we are going to use 2 functions. One is fill and the other one is arc. Arc function is going to draw a sector which we are going to fill with different colors. So also to make a ring, to make it hollow, we are going to draw a circle filled with black color. So for filling colors, we are going to use our colors list we defined in the constructor, and we're going to pass each color into the fill function before drawing the arc. And we're going to draw arc by using x and y position of the obstacle. And as the arc is a part of an ellipse, we need to supply all the arguments which we supply into an ellipse. So I'm passing in 300 and 300 for the width and height, and then we need to supply start angle and the end angle. So we will start from 0, so start angle will be 0 and the end angle will be half pi. That means covering a 90-degree angle from here to here. That means covering a quarter. And we are going to draw the remaining arcs in the similar way. So instead of starting from 0, we're going to start from half pi, and to half pi plus half pi, that means pi. So we're going to end into pi. So that means completing half revolution. In the next arc, we are going to start from pi and we're going to go to pi plus half pi. That means the third revolution we're going to make. And after that, we're going to create from half pi plus pi to 2 pi. Now let's fill this with a black circle. So fill 0, and we're going to draw an ellipse of the size 200 by 200 in the same position that we have drawn the arc. So essentially the ring is completed. Now we can draw it going to the sketch file. So in the sketch file, let's define a variable rotator, and we're going to initialize it in the setup function. So we'll call rotator equal to new rotator obstacle, and we're going to pass in our player that we have created before it. And then in the draw function, we're going to just call the method draw on it. Now let's go back to the browser and check it. So as you can see, the ring is being drawn with 4 different colors randomly. Now we just have to make sure that the one of the colors of the ring matches with our player. So we'll go into the rotator obstacle class and change one of its color to be the player's color. That means player.color that we have set in the class player. And then no matter how much we refresh, one of the colors of the ring's segment will be the color of the player. That means the player can pass safely. Now let's say no stroke into the player's draw function such that no color is visible around the ball. Now we can rotate this ring by using our offset. So what we'll do is we'll increase offset as we draw the ring. So each time the ring is being drawn, the offset will increase, and we'll add this value to the angles we have created. So all of the angles will be added with the offset. That will essentially increase all of the angles simultaneously, giving the effect of rotation. By the way, I edited multiple lines by using Alt and click, so you can press Alt and click multiple lines. Edit them simultaneously. As you can see, the ring is now rotating. Now as the player jumps up or moves up, we also need to move the ring below. So we need to create a move function in which we will pass in the distance, which will be subtracted from the y. And then we're going to call the move function into the draw function of this obstacle, and in the parameter value we're going to pass the difference traveled, which we will define in the player class. So this difference travel is just the distance which is the player is moving from the baseline. Baseline is just the line we have defined to measure the difference from the player's position. That will give the distance the player has moved up such that we can move the ring downwards. So initially the difference traveled will be 0, and the baseline will be at height minus 200. So remember that y value always increases downwards. So when we subtract something from the height value, we essentially go up. So the baseline will be 200 units above the base of the screen. Now to calculate the difference traveled, we are going to use this baseline. So we're going to do what? This dot baseline minus this dot y. So whatever is below will be greater. So baseline is below the player minus this dot y. If the player moves up the baseline, so this quantity will be positive. That means greater than 0. This is just another way of saying that the player has moved above the baseline. So if this condition happens, we have to calculate the difference traveled, and difference traveled will essentially be this dot baseline minus this dot y. So whatever we were checking in the condition, that will be the difference traveled, and the baseline will be shifted up by using the difference traveled variable. So you're gonna subtract the difference traveled from the baseline, so that means the baseline will be shifted up. And this can be understood by the code editor itself. As you can see, the lines are numbered, so from 0 to increasing order. So as you will subtract some number from it, you will essentially move up. The reason we are moving this baseline to the player's position is because we don't want to calculate the difference traveled again and again. That will essentially make our ring fall down rapidly. So we just move when the player goes up the baseline. And we also want to reset the baseline's position to its original position as the player falls down below a certain y value. So we don't want to increase the baseline to go out of the screen. So whenever the player falls down, we need to reset it. So for instance, this red dot is our baseline. So we will check if the y's position is greater than this, that means goes down. If the y's position goes down, then height minus 200. Height minus 200 is our red dot, so it falls below, that means is greater than this. So we're gonna reset it to height minus 200. That was when we constructed the class. And also in the move function, we need to make it plus, not minus, because we need it to go down. It goes rapidly down because we are creating our player in the middle of the window, which is much higher than the baseline. So we need to reset the player's position to be below the baseline. So we'll make it plus 100. Let's check it out. As you can see, the ring is continuously moving down. Doesn't matter, our player is below the baseline. So one thing we're gonna do is reset the difference traveled in the such that we calculate it from the start when we do the player's dot draw function. So in the draw function of our sketch, first the rotator will be drawn and then our player will be drawn on top of it. Let's now check it out. As you can see, if the player is below the baseline, nothing happens. As it moves up the baseline, the ring begins to fall down. Now we also need to reset the position of the rotator obstacle to be above the screen such that when we move up, the ring comes into the screen and it goes below. So for that, we are going to subtract a big value such that moving it out of the screen. So when we reset, it appears from the top as the ball moves up. So as you can see, as we fall down, the baseline again resets and then we can move up. So let's wind up this video and keep it simple. In the next video, we're going to create obstacles, collision detection. So whenever the player collides, it dies. So before going, please do like, share and subscribe. And also thank you for watching.